Welcome to all the students in the subject Industrial Management, the subject code of which RAS 601, and the topic to which I am going to deliver my lecture is PERT, that is Project Evaluation, Program Evaluation and Review Technique, and Project Crashing. The topic is taken from the chapter Project Management, and the unit is Project Management. The subject is meant for BTech 6th semester students from all the branches. The content which I am going through within this presentation are as introduction to PERT, that is Program Evaluation and Review Technique, an illustration of PERT, advantages of the method, limitation of method, as well as crashing of the project as the concept, and we will find out the reasons why project crashing takes place, and in that condition what we have to do further. So to start with the project presentation, the topic is project management, and the presentation for the last lecture, the fourth lecture, is as follows. With the introduction of the PERT, earlier we have seen about the CPM, and so I am not going to repeat it again. I am going to PERT, that is Project Evaluation and Review Technique. This technique was developed by US Navy basically, and with association of Booz Allen Hamilton, and they serves the US Navy and provide the concept of Project Evaluation and Review Technique during World War II. And thereafter this techniques develops in order to schedule the different activities in a project. Basically this particular type of technique is of probabilistic type, in which uncertainties are associated with the project, and so it is not deterministic type project like where the activity and time taken into activity are predefined. Here the time is not predefined. The time, however, it can be guessed, and if the conditions are all set, that is optimistic, then the time taken in activities is reduced to certain extent, whereas if the pessimistic time is taken into consideration, then obviously the time taken to complete the activity will increase, and the most likely time, that is again the probabilistic time, and the time that is guessed by the project leader or project executives by their experience. And so we combinedly find out the expected time by using a particular formula, that is expected time can be calculated to take into consideration both optimistic, pessimistic, as well as most likely time into consideration. And if optimistic time is represented by symbol A, pessimistic time is represented by symbol B, and most likely time is represented by symbol TP. T suffix P, that is probabilistic time or most likely time. Then, or we can use any other symbol also, then we can find out the time estimated as A plus 4 times of most likely time plus B, that is pessimistic time, divided by 6. It will provide me the average time. The time will not be optimistic, nor pessimistic, and it will be average of that can be placed in a beta distribution. Beta distribution is basically a kind of distribution, helps to find out the variation within the process, that is variation in terms of time. And if the variation is taken, mean variation is taken into consideration, then obviously it can be easily to assess the tenure for the project. In this particular technique, we usually consider the activity on arrow while drawing the network diagram. Next is probabilistic network analysis. Probabilistic network analysis based on the normal distribution and beta distribution. Here you can calculate the probability to complete the project by using the same formula used for finding out the standard normal distribution, that is z equals to x minus mu divided by sigma, where mu is the mean time to complete the project, whereas sigma is the standard deviation, x is the time taken in order to complete a particular activity. X can be replaced by xi. I stands for the stands for the activity, and ij is the activity between the node I and j, and z is the number of standard deviation in terms of x from the mean. And here it can, once we know the value of this probabilistic model, then we can easily find out the standard deviation and variation within the process. In the next slide, as I told you earlier, that it's a PERT is the probabilistic time estimate based technique, and here the activities and the time taken into activities are not certain, and beta distribution is used to calculate the PERT. The mean time, mean expected time, can be calculated by taking the formula as T mean time is equals to A optimistic time. Here M is taken into consideration for most likely time, plus 4 times of mean time or most likely time, plus B, that is pessimistic time, divided by 6. This is the formula to calculate the mean time. Students, please note it into your consideration. Like in CPM earlier, we consider the here will not consider the single time, where earlier we have given the definite time. Again, the variance can be calculated by using the formula by taking the difference of pessimistic time, that is more as compared to the optimistic time, so B minus A divided by 6 to whole square. The variance within the time can be calculated by this formula. Next, we will see the beta distribution in all the three cases: when optimistic time is taken into consideration, when pessimistic time is taken into consideration, and when most likely time is taken into consideration. Here you can see in all the three conditions, you can see T represents the graph is given to you as for the beta distribution in between time and the activities that are carried on. And here you can see that first diagram, A is the optimistic time, that is shown to you. B is the another end, that is pessimistic time, negative time, when all the situations goes worst, and then we can say that it will be the condition of pessimistic to take pessimistic time into consideration. And when the things are going optimistically, then obviously the tenure will reduce, because the activities, as the activity will smoothly conducted or passed, then it will be easy to complete the project. And mean time is shown to you, it's taken as 4 times. So you can see the variation is like that, where M, the value of mean time, most likely time, is more. Here again, a notable thing is that why the shape of the curve is like that. The shape of the curve represent that out of number of times if the activities is carried out, then the mean time to, or the most likely time to which the activity will complete, represents the highest or peak point of the project. Whereas in the second diagram, again you can see that if the pessimistic condition is taken into consideration, then the most likely time shift somewhat on x-axis in the rightward direction. And in the last diagram, you can see if all the things are going in symmetrical manner, like the optimistic time is as same as is varies in the same proportion as the pessimistic time varies, then we can find out the variation in the process. It will be symmetric and it will be as same as the diagram, third diagram represent over here. Next is an example we will be taken into consideration. Again, here the network diagram is drawn in which the activities are taken into arrows, in the form of arrows, whereas nodes are representing by circles. And here you can see that for a particular problem, the solution is represented in the form of PERT. Here our purpose is not to draw the network diagram. Here our purpose is to find out the time, the most likely time and mean time and variance within the process. And so I'm not considering that as the question of drawing the network only. And so here I have given a network to you already for a given problem, and we have to find out the mean time as well as the variance within the process. So here you can see number of activities and the relation preceded with the precedence and successive activities are shown to you in this diagram. Here you can see the dummy, two of the activities are represented as dummy, and this dummy activity is in between node 2 to 5 and node 7 to 8. Here 2 is the normal activity can be considered, and if 2 to 5 is not given in the question as dummy, then there's no need to mark dummy, whereas in case of node 7 to 8, if we not connect it unless and until in the question it is not asked, then the network will be somewhat incompleted, and so it is given to you in the question itself that 2 to 5 is the dummy activity, whereas 7 to 8 is also a dummy activity. That is why we have closed both these with the help of a dashed arrow. Next we have given with the optimistic and pessimistic time. Here you can see that activity 1 to 2, 1 to 3, 1 to 4, 2 to 5, 2 to 6, 2 to and 3 to 5, 4 to 5, 4 to 7, 5 to 8, 5 to 7, 7 to 8, 6 to 9 and 8 to 9 are represented, and these activities are represented earlier in the previous slide. A network diagram is shown represented, and for which these activities are given to you, and it is given to you that optimistic time A, pessimistic time B, as well as most likely time M is given to you. You can see the difference between all these times. Here you can observe the value of A in each activity is the lowest among A, M and B, whereas the value of B, that is when we consider pessimistic time, then the weeks time estimation in terms of weeks are increased. For activity 1 to 2, it is increased as it is taken as 10 weeks, whereas for the activity 1 to 2, that is 2, that is the same activity. If it is considered as optimistic activity, then the time taken into completion for the activity is as 6 weeks, whereas most likely time is the time in between the pessimistic and optimistic time, that is of 8 weeks. Similarly, you can see here each and every activity is associated with optimistic, pessimistic as well as most likely time. Here we can calculate the mean time for each and every activity by taking the formula into consideration, and as well as we can also find out the variance. Please note it down, mean time is T. Here by mistake it is shifted and shown above the pessimistic time t, but it is mean time is equals to t, whereas variance is sigma square. I am repeating it again. By mistake, the t is shifted in leftward direction, as well as sigma square is also shifted in leftward direction. That is why it is seem to you that b and t are same, but not same. It is b is the optimistic time, whereas t is the mean time. Variance is represented as sigma square. Mean time can be calculated for each and every activity by using the formula a plus 4 times of m plus b divided by 6, and it can be seen that mean time for different activities is represented as 8, 6, 3, 0, 5, 3, 4, 2, 7, 4, 0, 4 and 9, etc. Whereas variance, the formula for variance is, earlier we have seen, that is formula for variance is sigma square. Sigma square is equals to b minus a, that is pessimistic minus optimistic, divided by 6, and it is calculated as for the different values of pessimistic and optimistic time. The value are 0.44, 1, 0.44, 0.0, 2.78, 0.11, 0.11, 0, 1.78, 0.44, 0, 1, 4, etc. Here in this slide you can see we can calculate early as well as late time. As we know about the mean time and variance in the process, we can find out earliest start time, earliest finish time, latest start time, latest finish time, total slack and free slack or free float. As I told you earlier that these are the values to which you can calculate by using different formulas, like for calculating EST, we just take into consideration the time taken by the activity. The time taken in between the two nodes is as same as the EST. It stands for earliest start time, and if there is no predecessor activity, then it will be 0. And in order to calculate the earliest start time for the successor activity, we have to just add the time taken into consideration, time taken to complete the activity, with the time taken into the precedence activity. Next is EFT, earliest finish time. Earliest finish time can be calculated by using the summation of earliest start time plus time taken into activity to perform the activity. Earliest finish time and latest finish time from the backward pass method can be calculated by LST can be calculated by LFT minus TIJ, that is latest finish time minus time taken to complete the activity, the previous two activities, that is I to j. Next is slack or free slack or free flow. This we can calculate by using the formula that also provided to you in the last slide, in our last question. Next, as and when we come to know about earliest start time, earliest finish time, latest start time, latest finish time, and the time taken into the activities, that we can easily calculate the cost associated with the probabilistic model. That is, with the PERT analysis, we can also find out the cost of the project. Again, here, in order to find out the variance of the project in totality, we have to find out, we can calculate it by taking the summation of variances along the critical path. Like, if I know the critical path passes through nodes 1, 3, 5, 8, 9, then for the path 1, 3, 5, 8, 9, if the variance is known to me, that is in between 1 to 3, variance is 1. For activity 3 to 5, variance is 0.11. The variance between the activity 5 to 8 is 1.78, and that of between 8 and 9 is 4. After calculating the variance in between the different activities that are representing the critical path, we can calculate the total project variance by adding all these variances. By summation, the total project variance can be represented in terms of sigma square as equals to 6.89 weeks. Here, my dear students, this is variance, and we don't have to calculate standard deviation over here, and so this is the only variance 6.89 weeks. It will be taken as it is. You need not to calculate root mean square of this value. Next come to the advantage of PERT and CPM. Earlier I have conveyed the advantage of CPM also. The same are the advantages associated with the PERT also. However, PERT is having an advantage associated with it, that it is the probabilistic method. In case of CPM, where the model was deterministic nature, the values were defined, that was deterministic nature, and so there's no problem to calculate the scheduling time as well as cost of the project. Here the project is and the values are of varying in nature, and so here the network generated provide valuable project documentation and graphically point out who is responsible for various project activities and how he managed the variation in terms of optimistic time, pessimistic time, and most likely time. Again, all this analysis is applicable to the wide variety of project and industries where the uncertainty is there in terms of actions, as well as this particular model is relevant, this particular technique, scheduling technique, is relevant for the project where the variation usually associated, where the variation proportion is very high and the activities and their certainty is not decided, not confirmed. And this particular analysis is useful in monitoring not only the schedules but the cost as well. As I told you earlier, that we can find out the sequence of operations as well as the cost associated with the project with the help of this type of scheduling techniques. Both CPM as well as PERTs are equally important from this point of view. Last but not least, there are a number of positives associated with this technique. However, the technique is subjected to some limitations, you can say, and these limitations are: first is the limitation, that is, it is assumed clearly and defined, independent and stable activities. So all these assumptions, all these things are based on assumption and it is not accurate. The time estimation based on this technique will not be the exact one. Yes, of course, it's a big limitation of PERT, that is Project Evaluation and Review Technique, that it provides a kind of rough estimation and not the exact one. The second limitation that is associated with PERT is that it specified precedence relationship only and not with the successive relationship. Yes, you can see it is based on the precedence relationship. The variables are not independent because each and every activity within the project are interdependent. Once one of the activity takes place, then only the another activity can start or can initiate. And so it is a time taking process, and where the values of in terms of time and cost are dependent on the activities and the time taken into activities in the previous activity and the cost associated with that. Next disadvantage, or you can say limitation, associated with PERT is the activity time follows the beta distribution, whereas earlier these distribution are based on probability itself. And so yes, of course, the basis of this technique is probabilistic, and so it's a big limitation of PERT analysis, that it is not free from the effect of beta distribution. Next is the subjective time estimates. Like, unlike the CPM analysis, it's a subjective time estimate and associated with the subjective parameters, and so this is another limitation of PERT. And last is overemphasis on critical path. Yes, we can see that to find out to draw the network diagram, by drawing the network diagram, we can find out the different estimations in terms of the minimum time taken in order to complete the project, maximum time taken in order to complete the project, and other normal time, other variations in terms of time within which the project can be completed. Yes, but our analysis are basically more relied on, emphasis is more on in the estimation of critical path only, and not on the minimum time. So these are the limitations of PERT analysis. Next, we will move towards an important topic, that is project crashing. As the name suggests itself, when all the things goes wrong into in terms of direction, in terms of cost, in terms of methodology, then we can say the project crashing takes place. In that particular condition, in project crashing condition, the project will not complete within the specified time, and this crashing may be in terms of cost, in terms of time, and the direct cost and indirect cost associated with the project. And so all these parameters varies as and when the project crash takes place. And in order to manage the things, resource smoothing, resource leveling takes place. We have to level out the resources, we have to smoothen the resources in order to by providing the additional budget, by providing the additional limit in terms of time, and so that we can reduce the effect of crashing to some extent. However, in terms of time, we cannot reduce the effect of time just because of the fact that the time which passes once that cannot be repaid or back again. So with this, this unit comes to an end, and this topic as well as this unit both comes to an end. Thank you students for your